Uh, this second tutorial is just for sake of one word that you need to be able to define it and give example for, and that's homologous series. Now, homologous series, if we ask you to deduce it or describe it, is a family of organic compounds have the following four criteria or characteristics. First of all, they have the same general formula if it's a homologous series. Then the neighbors, they differ by CH2. As you go on and get bigger, you're getting bigger by a fragment of CH2. They have the same or similar chemical properties. For example, they all can burn, go through combustion. And they will show a gradual change in physical properties. Most important is boiling point. So as example, I go after some families. The first one I go after is alkane. Now I'm going to give you the first few members. Methane has one carbon. It's saturated CH4. Now the second member has two carbons, CH3, CH3, or you can write it as C2H6. The third member, propane, has three carbons, so it's a CH3, CH2, CH3. Condensed formula is C3H8. Now I don't have much room for butane. I'm going to give you the condensed. So C4, you should be having two more hydrogen compared to before, so it's C4H10. And finally, for pentane, if I give you as example of alkane, it's C5H12. So they should have the same general formula, and generic formula or general formula for alkane is Cn, N is an integer, H twice as much, 2N plus 2 more. So they have the same general formula. Now they all go through combustion, so they have similar chemical properties. If I give you boiling point for this group, CH4 is a gas. The boiling point in degrees Celsius for methane is minus 164 degrees Celsius. So it's already a gas at room temperature. Ethane is minus 89, so there is an increase in that, but it's still a gas. Propane is minus 42. Butane is minus 0.5 degrees Celsius. And finally, pentane is becoming a liquid, and it's 36 degrees Celsius boiling point. Room temperature being 25. So the first four members gradually are increasing or gaseous. The fifth one is a liquid and also gradual increase. Now let's look at another homologous series as alcohols. Methanol, met stands for one carbon. It's CH3OH. OH is hydroxyl, represent a functional group for alcohols. The next member is CH3, CH2OH, ethanol. And the third member is propanol, which is three carbons, CH3, CH2, CH2OH. Now for generic formula for this, I can put R, which is a radical or an alkyl group. This segment is R, this is R. Examples of R, this is methyl, ethyl, and propyl OH. So they have the same general formula. They go through similar chemical properties. And if you look at their boiling points, then again in degrees Celsius, now what you notice is gradual increase in boiling points. Methanol is 65 degrees Celsius. It's liquid at room temperature. Ethanol is 78.5 and propanol is 97.4. One thing you should note at this stage is why methanol has such a large boiling point compared to methane. And that's where I want you to remember your intermolecular forces. This one has hydrogen bonding, which is very strong and make the molecules sticky. They stick to each other. This one has no hydrogen bonding. Hydrogen has to be attached to oxygen, nitrogen, or fluorine to be hydrogen bonding. This simply has van der Waals forces, which are the weakest and cannot compare. Now let's look at another functional group known as carboxylic acids. The first member is methanoic acid, has only one carbon, so COOH, and there is an H in front of it. If I elaborate the structure, it looks like this: double bond O, single bond OH. Ethanoic acid is CH3COOH. If you compare it, the difference between methanoic and ethanoic is CH2, so they're increasing by CH2. Propanoic is CH3, then again one extra CH2, COOH. Now if you look at their boiling point, then again there is a gradual increase in boiling point. This one in degrees Celsius is 101, liquid at room temperature. Ethanoic is 118, and propanoic is 141. Then again, I want you to also further compare them. Why methanoic acid now has even larger than methanol? Because not only I have hydrogen bonding here, but I also have additional dipole-dipole. So the boiling point drastically goes up. The generic formula for carboxylic acid could be represented as RCOOH. Then again, R is this alkyl group that you see here, even hydrogen. Now, the last slide I'm going to show for this segment is just a comparison of boiling points of alkanes. So this is alkane group, and I have shown methane, CH4, ethane, propane, butane, pentane, and even hexane. And you see pentane and hexane are becoming liquid. They go above room temperature. And then I've shown you alcohol family, the first three members, that you should realize they have hydrogen bonding stronger than intermolecular forces than alkane, but gradual increase. I also have shown you carboxylic acid as red, and then not only I have hydrogen bonding, I also have further dipole-dipole, therefore I have higher boiling point than alcohol.